attention. The first number is the radius, and the second number is our angle. Okay, so this first point is 490 degrees. So what that means is we're counting by, so this is 0, this is 90, this is 180, this is 270, this is 360, right? Okay, so 90 degrees would be here, and the radius of 4 means you're on the 4th ring. So 1, 2, 3, 4. You see where I have my laser? Put a point right there and label it A. All right, so the second one is 210. So 210 degrees, that would be right here, right? And what's the radius? What is it telling me to go out? How many rings? 3. So that would be 1, 2, 3. Put a point right there. That's point B. And then we have 120. So let's talk about what a negative radius means. If your radius is negative, that just means we're counting back. So I'll explain what I mean. 120, this is 120 right here. Normally, I would go forward like this. But because the radius is negative, I'm going to count back, and I'm going to end up right here. Okay? So point C is here. Point D, positive 60. So this is 60. But it's a negative radius. So instead of me going forward, I'm going to count back. 1, 2, 3, and I'm right there. That's called point D. And then we got point E. So now for point E, I want you to notice that we have a negative radius and we have a negative angle. Okay. A negative angle, that means I'm rotating this direction. Okay. So I'm going to go ahead and erase this, and I'll put it back if I need to. But when we're talking about negatives, this would be 0. This is negative 30. This is negative 60. This is negative 90, etc. So negative 330 would be right here. Okay. So negative 330, this is negative 330, but because it's a negative radius, I'm also going to count back 1, 2.5. So that point is right in front of B. All right, next is F. So we got negative 45. So negative 45, that would be right here. But this is positive 5, so I'm going to count forward, and I'm going to land right here, right on the edge. That would be point, where we at, F. And then lastly, point G. 180, but it's negative. So what does that mean? I'm going to count back 1, 2, and I'm going to land right here. All right, any questions so far about how to graph a point? Now, your project is in radians. And I know we don't like radians, but if you turn it in degrees, you automatically lose 10%. So in order to get an A, you have to do the project in radians. So now let's practice. And this time we're going to use radians. So when we count with radians, this is 0. This is pi over 6. I'm not going to label the whole thing. Pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi. Let's just stop there. And then you would just keep going. And if you don't remember, take out your unit circle, and you can use that as a reference. So my first point says 3, 5 pi over 6. So 5 pi over 6 is right here. And I'm going to go forward 1, 2, 3. So I'm going to land right here. This is point H. Point I, positive 2 pi over 3. But I'm going to count backwards because it's negative 1, 2. I'm going to land right here. That's I. J, I'm on pi. Am I going to count forward? Am I going to go backwards? Forward because it's positive 1, 2, 3, 4. So I'm right here. 3 pi over 4, that's here. It's not labeled, but this is 3 pi over 4, but it's negative, so I'm going to count back 1, 2, and it's going to look like it's right next to I. So K is really close to I. And then we have L, which is 11 pi over 6. 11 pi over 6, that's here, and it's a positive 3, so that would be 1, 2, 3, so right here. Did you need something? Oh, okay. So right here, bye. This would be L. So it's like we got a whole bunch kind of clustered together. And then we have M, which is pi over 6, but I'm going to go backwards. 1, because it's negative, right? So we got 1, 2, 3, 4, so it's going to be here. Lastly, 3 pi over 2. It's negative 3 pi over 2. So negative 3 pi over 2, if you count backwards, 1/2, 1, 3 halves right here. Because it's negative, I'm going to count back 1, 2, 3, 4, 5, and N is right here. Any questions about how to plot points? Okay. So now I want you to practice naming points. So I'm going to call this point A. Can somebody give me one name for that point? One name. Yeah, what's our angle?
5 pi over 6.
So, okay, 5 pi over 6. And then what's our radius?
4.
Good. All right. Can we do that with a negative radius?
Yes.
So what if I want somebody else? What if I want to use -4? What would be the angle that I would use if I want to use a -4 as the radius? 11 pi over 6. Good job. All right. What if I want a negative angle? Still on A. What if I want positive 4, but I want a negative angle? So we're going this direction. So this is 1, 6, 2, 6, 3, 6, 4, 5, 6. This would be 7. Oh, actually, that would be 7.
Yeah.
-7 pi over 6. All right, so we all kind of get the point there. All right, now let's talk about this one. We're going to call this one B. Somebody give me a name for point B.
Is it 5? Not 5 pi over 3.
Wait, what were you going to say, Jaden?
I said 2.
Yep, 2. The radius is 2.
I can't remember the radius. Yeah.
I mean, I would take degrees, but just again, on the project, it has to be in radians. But you can tell me, and for this purpose, you can tell me degrees or radians. So 2 who? 2 300, yep. Which is 5 pi over 3, by the way.
Yeah.
What if I want to use a negative? What did you say, Jaden? I like it. What if I want a negative angle? I want to use 2, but I want my angle to be negative. Negative 60. All right.
What's the radius of that?
Pi over 3. Negative pi over 3. All right, so how you guys feeling so far?
Yes.
All right, let's go to the next page. Let's practice graphing the different types of polar. These are the most basic. You're not going to use these for the project. But if you're asked to graph, if you do r equals 2, that is a circle. And all you're going to do is trace, oops, that's kind of sloppy. Trace that ring. That's what a radius, that's what the graph r equals 2 looks like. If you're asked to graph an angle, that looks like a line. So, yeah, but it goes all the way through. I'm sorry, y'all. I don't mean to y'all. That's rude. All right, 1 over 6, 2 over 6, so 4 over, so this would be here. So even though that 2 pi over 3 could really have 4 different names, and it's going to look the same. So the graph of 2 pi over 3 looks the same as 5 pi over 3. And then negative 7 pi over 6, now I'm rotating this direction. That would be here. And that looks the same as 5 pi over 6. So now let's practice naming these graphs. So we have our first one. This is going to be a line, so it's going to be theta equals, somebody give me one name. In radians, let's go back to radians.
Pi over 6.
Pi over 3.
Oh, yeah.
Now this part could also be, now what would this be? Because we could also use this piece. So that would be theta equals what?
Would it be negative?
Well, no, I'm still going this direction. But if I'm going this direction, what would this angle be? Yep, it would be 4 pi over 3. All right, now let's go backwards. Now let's do 1 negative. So if I'm going this way and I stop here, what would this be? Negative what? Yep, negative 2 pi over 3. Good job. All right, a circle is easy. What would that be? R equals what? 4. C, R equals what? 2. All right, now let's talk about this line. What would that be?
Pi, 2 pi over 3.
Yep. Or what would it be if it's negative?
Is it 5 pi over
1 over 6, 2 over 3, 4, 5, 6, 7, 8. 8 over 6. So I have negative 4 pi over 3.
Okay.
Yeah. All right. I think you all are kind of getting it, so that's good. So I think the problem I did in 5th period was I tried to graph, and that was doing way too much. So I'm not going to graph, but I'm just going to introduce you to the 5 different types of graphs. We're not going to actually graph any though. All right, because you need to kind of know what it looks like. So when you have a circle, just know you can do a cosine circle or a sine circle. Cosine is going to point left and right. A sine is going to go up or down. So I'm just going to do some sketches. These are by no means are they accurate. But if I say positive 2 cosine theta, that's going to look something like this. Well, that's really a 3 because I went out to the 3rd ring, so we'll say 3. And if I say r equals negative 3 cosine theta, then it's going to go out to the 3rd ring. It's going to look like that. About. If I said r equals positive 3 sine theta. It's going to go up to the third ring and it's going to come down. So it looks more like an oval than it really does a circle. But we just call it a circle. And if I said that sine was negative 3 sine theta, then it would go down. Okay, does that make sense? That's the first kind of graph. Now, I will tell you, as far as points, this has the lowest point value because it's the most simplistic of all of the graphs. It's still good, but it's the lowest point value. So circle is the first one. The second one is called a Lie Mason. This is the only one that has a plus or minus in the equation. And I'm not going to spend a whole lot of time talking about it, but I'm just going to draw a couple of, and again, I don't want to get too complicated, but when you do it, you have two numbers being added or subtracted. So if you say, for example, 3 plus 4 cosine theta, this is kind of hard to graph though, because what this is going to give you is an inner loop. So I'm going to kind of do my best. So it's going to look like you have a little circle and then a big circle. That's what that looks like. But I have found that that's one of the harder ones for people to actually duplicate on the board, okay? If you just wanted to look more like a heart, then you would use the same number. So let's say 4 plus 4 cosine theta. And of course, this could be sine if you wanted to point up or down. I'm just using cosine. That's going to look more like a heart. Something like that. I know, heart-ish. And if the first number is bigger, then it still has like, but it doesn't touch the middle. It looks more like that. So now tomorrow when we actually graph it, we're going to use technology and I'm going to show you how to use the calculator and it'll kind of all come together. But I just want you to kind of have an introduction of what they look like. All right. Yes.
So the drawings, would it be like, are we supposed to draw those in our notes?
It's up to you. I'm just giving you an approximate image.
Okay.
And for the last one, why does it look like? What's that supposed to be?
Oh, wait, first of all, that's not even the right equation. Sorry. This should be 4 plus 5 cosine. So, wait. Let me go back. No.
Because if it's
No. Sorry. Let's say 4 plus 3.
Okay, so it has to be smaller.
Yeah, it has to be smaller than the first number. The difference is it doesn't, like, it's a heart, but it doesn't touch the origin. It's not going to come all the way to 0, 0. That's the difference between those two. So if you wanted to actually touch the origin, then you have to use the same number. It doesn't have to be 4. It could be 5. It could be 6. It could be whatever. Okay. All right. So then the lemniscate. Lemniscate is the only one that is squared. Starts with an R squared. And when we type it in, because it's R squared, we have to type this in under a square root. Okay. So there's two different types. If we decide to use a cosine, it's going to look something like this. So for example, if I wanted to hit the fifth ring, it would be R squared equals 5 cosine 2 theta. That would be an example of a lemniscate. And, wait, I didn't mean to, sorry, not 5, 25. And let's talk about why it's 25. What is the square root of 25? So if you have a lemniscate, that means it's going to hit the radius of 5. So what if I wanted to hit a radius of 4? What do you think I'm going to put in? 16. If I want to hit a radius of 3, I'm going to put a 9. Okay. Now, if I wanted to go up and down, I'm going to change it from cosine to sine. So that's gonna look something like this. And it's up to you to figure out what it is you want to put. All right, and then the last two, now roses get the most amount of points because they are the most complicated. Okay, so a rose, for example, if you have R equals 4 cosine 3 theta. I don't know why I'm leaning so hard on cosine, but I guess I'm feeling cosine. Okay, so if we do that, whatever number I put here, if this is odd, that's the number of petals I'm gonna have. And by petals, so this was gonna go out to the 4th ring, so I'm gonna say, and again, you kind of just do the best you can. These are your notes, so it's not, you know, that's what a rose would look like. So it really looks more like a daisy.
So if it was even.
If it's even, so let's talk about if it's even. So let's say it's R equals 4 cosine 2 theta. If this is even, the petals double. So if that's a 2, how many petals do you think I'm gonna draw? 4, yeah. So I'm gonna draw one that goes out to the 4th ring. It's gonna look something like this.
Oh, it goes to the 4th ring.
Yeah, yeah.
Oh, so basically the front number tells you
How far it's gonna go, yeah. And then the last one is called a spiral. And that's exactly that, it just spirals. It just keeps going out. It's a spiral. And this is the only one that has no sine or cosine. Okay. So, looking at this, on the final, you won't be asked to graph a polar. However, you will be asked to identify what type of the 5 each one would represent. So what do you think number 1 would be? It starts with R squared. The only one that starts with a square is called a what? Lemniscate. And I'm not really worried about spelling. All right, number 2 doesn't have a sine or a cosine. The only one that doesn't have a sine or a cosine is called a what? Spiral. Good. This one, what do you think 3 is? A rose. Now, I'm going to go ahead and answer these together. All of these have a plus sign in it. Only those 2 have a plus sign in it, which means that they are lemicon. All right, number 5. What do you think 5 is? It has a plus sign.
But it doesn't have
Oh, but it doesn't have a sine or cosine. So what would that be? Spiral. All right, what about 6? Circle. In order for it to be a rose, a circle and a rose look similar, but the only way it could be a rose is if that theta was multiplied by something other than 1.
so 7 is a rose.
7 is also a rose. Good job. And what about number 8? Circle. All right, so we're going to end there. But what I am going to do is I'm going to show you the calculator on Canvas. Yes, so